Hey everyone, today I'm solving the problem maximum subarray. This is a classic problem that introduces Cardano's algorithm. We need to find the contiguous subarray with the largest sum. We are given an integer array and we need to find a contiguous subarray whose sum is maximum. So contiguous means the element must be next to each other. So basically, among all the possible subarrays, we need the one with largest sum. Let's first think about the brute force solution. The most straightforward idea is to generate all the possible subarrays and calculate their sum. I will maintain a variable called maxi to store the maximum subarray sum found so far. I initialize it to int min because the array can contain negative numbers. The first loop fixes the starting index of the subarray. The second loop fixes the ending index of the subarray. So for every pair ij, we are defining a subarray from index I to index j. Now, to calculate the sum of the subarray, I use the third loop. This loop runs from I to j and keeps adding element to compute the total sum. After calculating the sum of current subarray, I compare it with the maximum sum found so far. If it's larger, I update the maximum. So effectively here we are checking every possible contiguous subarray. For each one we compute its sum and we keep track of the maximum. So let's analyze the time complexity here. The outer loop runs for n times and the second loop also runs for n times, and the inside that the third loop also runs n time. So overall the time complexity becomes n cube, and we are only using few variable like sum and maxi, so the space complexity is 1. While this solution works logically, it is extremely inefficient for large input. So now let's try to optimize it. In the brute force solution, the main inefficiency was the third loop. For every pair of I and j, we were recalculating the sum from scratch. Notice that when we fix a starting index I, we don't need to recompute the sum every time. If we already know the sum from I to j minus 1, then the sum from I to j is simply previous sum plus nums of j. So again I initialize, let the maxi be initialized to int min, and the outer loop fix the starting index of the subarray. For every new starting index, I reset the sum to 0. Now the inner loop extends the subarray. Instead of using a third loop to compute the sum, I simply keep adding nums of j to the running sum. This way, we can avoid recalculating the same element repeatedly. After each addition, I update the maximum subarray sum. So, For every starting index I, we explore all possible subarrays starting from I, but we compute the sum incrementally. This removes the third loop. So the outer loop runs for n times and the inner loop runs for n times. So the total time complexity becomes n square and the space complexity is also 1. This is significantly better than n cube but still not optimal. Now let's see if we can do even better. Instead of checking every possible starting index, can we solve this in a single pass? The key observation here is if the running sum becomes negative, there's no benefit in keeping it. Suppose the sum of element so far is negative. If I add this negative sum to any future element, it will only decrease the total. So, whenever the running sum becomes negative, we discard it and start fresh. So, now let's see if we can do even better. Instead of checking every possible starting index, we can solve this in a single pass. The key observation is this: if the running sum becomes negative, there is no benefit in keeping it. Suppose the sum of elements so far is negative. If I add this negative sum to any future element, it will only decrease the total. So, whenever the running sum becomes negative, we should discard it and start fresh. So, here the maximum stores the maximum subarray sum found so far, and sum stores the current running subarray sum. Now I iterate through each element in the array. For each element, I add it to the running sum, and after updating the running sum, I compare it with the max sum. If the current sum is larger, I update the max sum. If the running sum becomes negative, I reset it to 0 because a negative prefix will only reduce the future subarray sum. It is better to start a new subarray from the next element. So, we traverse the array only once, and the time complexity is n, and also the space complexity is 1.